Okay, we're going to look at reviewing for our midterm. I split this into two parts, the first part being review of Module 1 and 2. So let's get started with this first part in Module 1, and we're going to look at number 1 here. It says, Jim has a job paying $9 an hour. Write an expression for the amount of money Jim will make when working X hours. So if we know, if I underline some key points here, $9 per hour, and our variable would be X hours, we're just going to say that's 9X. And that's our expression. Number 2, if a car rental company charges $1.15 per mile plus a one-time charge of $60, what would be an expression for the total charge from the rental car company if you drive M miles? So again, I want to highlight some important features here. I've got $1.15 per mile, that's a rate. I got $60 as a one-time charge, and then my variable this time is going to be M. So I know the 1.5 is my rate, so I multiply that times the miles. And then I need to add that additional $60 as the one-time charge. And that would be our expression for number 2. Okay, let's go on to number 3. It says, write the simplified algebraic expression that represents the following sentence. It says, multiply a number by 4, subtract 5, add 10, all divided by 5. So I want to write this in that order, starting by multiplying a number by 4. So I'm going to say 4 times some number. From there, I want to subtract 5, add 10, and then take all of that divided by negative 5. Another way I could write this, since I can combine these two terms, the negative 5 and the 10, would be 4n plus 5 over negative 5. Either way, it's fine. Looking at number 4, it says simplify the expression. Remember, we want to use the order of operations. Order of operations. And remember, that is parentheses, exponents, multiplication and division, then addition and subtraction. So we need to use PEMDAS, or order of operations. If I write this off to the side, I want to start with parentheses. Well, I actually have parentheses within my parentheses, so let's start with the inner ones first. So I've got 3, and then 2 minus 3 is negative 1. Next, I have these parentheses, so 3 and negative 1 plus 5 is 4. And then finally, 3 times 4 is 12. So remember, order of operations for that one. Next one says, write the algebraic expression that represents the verbal sentence. So we've got 2 added to the product of a number and 7. So I actually want to start with this product of a number and 7, and then I'll add 2 to it after. So if I want to take a number times 7, I'm just going to say that's 7n. From there, I can do the additional 2, and my expression is 7n plus 2. Okay, looking on to number 6 here. I give an expression y over 2 plus 6, and the directions say for x equals 1 and y equals 2, evaluate. So really, when you're given a situation like this, we just want to plug in 2 for y, 1 for x. Again, we're going to use the order of operations. Division comes first. So 2 divided by 2 is 1. 1 plus 1 is 2. All right, number 7, since we have a variable in here and there's no value given for x, we just want to simplify. So we're going to end up with some type of expression involving x and some numbers. To do that, since we can't combine anything in here, we're just going to multiply this negative 3, distribute the negative 3 out. So if I distribute the negative 3 times 2x, I get negative 6x. The negative 3 times negative 1 plus 1. From there, combine like terms. Well, I got a 5 and a 1. That gives me negative 6x plus 6. And that's as simplified as I get. Okay, number 8, it says determine which expression is larger if x is greater than y. So what this is saying is, in this situation, x is always a larger number than y. So an example could be if x is 2 and y is 1, or you could have something where x is 100, y is 20. It doesn't really matter, just all those values where x is greater than y. So we want to look at this first example. X minus y and y minus x. Which one is larger? Well, if I take a large number minus a small number, and I'm going to compare it to, that's x minus y, a large minus a small, and I'm going to compare it to a smaller number minus a larger number. And again, I know that because that's what's given. X is a larger number than y. Well, when looking at that, the value that's going to be greater has to be a large minus a small, because a small minus a large is going to be a negative number. So this one would be a positive number. This one would be a negative number. So I'm going to say my answer is x minus y is larger. If I look at B, I have a fraction here. It might be useful to write this actually as a fraction looking like this. And what I notice is the numerators are the same. It's going to be the same number. So really I'm comparing the denominator. And when I compare denominators, I need to think about if x is larger than y, which number is going to be larger? Well, let's be careful here. If I do a quick example of 1/3 and 1/2, which one's larger? Well, 3 is the larger number, but 1/2 is actually the larger value. So we want the smaller number in the denominator because that's going to give us the largest overall value. So what I want to say then is x times y over y is, and actually let me make that red like I did before, is larger. Remember, that's because the denominator is going to be a smaller number. And a smaller number in the bottom means a larger number overall. Let me circle that. I'll circle the last one too. Okay, number 9, another simplifying one. This one's a little more involved. Again, we have a variable in here, so we need to do some distributing first. This 3 getting multiplied out because that's the very inside parentheses. I'm going to write what I have initially and say 3 times 4x is 12x. 3 times negative 2 is negative 6. From there, let's stick in the parentheses. I've got to combine like terms. So I have negative 6 and positive 2 gives me negative 4. Another distribution, that 3 gets multiplied to both terms. 4 plus 36x minus 12. And then lastly, another combined like terms. Well, 4 and negative 12 give me negative 8. And I'll put 36x out front. And then minus 8 after. There we go. Okay, number 10, we're going to start with Module 2 now. Module 2 dealt with more equations. So this first one has you set up an equation and solve. So the situation here is a checking account is set up with initial balance of $1,800 and $180 is removed from the account each month for rent. How many months will it take for the account to reach $0? So I want to highlight a few key things. Obviously the initial balance. And then I want the 180 each month, so there's a rate. And then I want to know how long it'll take to be $0. So I know I want this to equal 0 because I want to know how long it'll take to equal $0. My initial balance is the $1,800. So I have $1,800. I'm going to subtract out my rent. So it's 180, and then that's a rate per month. From here, I'm going to solve for m, so that means subtract the 1,800. Negative 1,800 equals negative 180m. From there, I can divide the negative 180. And you get m equals 10. So let's relate this back to the problem. It says how many months, remember m stood for months, so we're going to say it's 10 months until the account reaches 0. Okay, number 11, is x equals 2 a solution to the equation? Why or why not? So when I get one of these, there's two methods you can do. Method 1 is we can just plug in x equals 2. So let me do that method. I'm going to say 4 times 2 minus 2 equals 3 times 2 minus 1. 4 times 2 is 8. 3 times 2 is 6. 8 minus 2, 6 equals 6 minus 1 is 5. So it's obvious when I plug in x equals 2, it does not give me a true statement. So that could be my reason. I could say no because 6 does not equal 5. Or I could look at method 2. So let me scroll over here. Method 2, I could just solve the equation. If it ends up equaling 2, then I know I'm right. So just solve the equation. 4x minus 2 equals 3x minus 1. Well, let's subtract 3x. X minus 2 equals negative 1. Add 2. X equals 1. So again, I could say no because x equals 1. So two options there. Either one is fine for as far as an explanation that you might see on your exam. Question 12, is the value of x equals 2 a solution to the equation below? So I give you a different equation, still checking if x equals 2. This one might be easier to do method 1. Just because we have this x cubed, it's going to be hard to just straight up solve it. So method 1 might be the way to go. We're going to plug in x equals 2. So I've got 2 times 2 minus 3 equals 2 cubed minus 7. Well, on the left side, 2 times 2 is 4. On the right side, 2 cubed, remember that's 2 times 2 times 2 is, well, 2 times 2 is 4. Times 2 again is 8. And then 4 minus 3 is 1. 8 minus 7 is 1. So 1 equals 1. You better believe it's a solution. X equals 2 is a solution. Okay, look at number 13. It says solve the equation. So we're going to solve this just like every other equation, where we need to get all the x's on one side, the constants on the other. So let me subtract the 3.2x first. I'm left with 1.1 equals 1x, or just x, minus 1.1. So from there, I'm adding the 1.1, and I get x equals 2.2. Remember, if you need to check, if you're unsure about something like this, especially if it's a decimal, we'll go back to what we just did in method 1. Plug it in, see if this, when I plug in 2.2, works out. When I plug this into a calculator, I get 8.14 on the left, and I get 8.14 on the right, so that means I know that's a working solution. So you can always go back and check these equations. Okay, 14 looked at solving equations that deal with fractions or rational equations. So remember our strategy. Our strategy for solving these equations with fractions. We want to multiply the equation by the least common denominator. So if I compare these denominators, 4, 4, and 2, the least common denominator is 4. So our LCD in this case is 4. That means I'm going to take my equation and multiply all of it by 4. So, let me write this out step by step. A lot of people do this next step in their head. But I have 4x over 4, and then I have 4 over 4, and 4 over 2. Things start to reduce on the bottom because 4 over 4 cancels. Here I just get 1, and then 4 divided by 2 is 2. So let me write x plus 4 divided by 4 is 1 equals 4 divided by 2 is 2. Much easier equation to solve now. So I'm going to subtract 1, and x is 1. Again, you can always go back and check. If I plug in 1/4 plus 1/4, I do get a half. So remember the strategy, multiply by the LCD. Okay, 15, solve the equation for A. So I'm given a equation, mainly variables, and I need to solve this for A. So in other words, get A by itself on one side of the equation. Get A by itself. Those are supposed to be quotes for A. So if I write this down again and say, how do I get A by itself? Well, this one's not too bad because 2b is being added to it. So let's just subtract 2b from both sides. And actually in one step, we just got A by itself, j minus 2b. Okay, 16 says, how many long sleeve shirts can the store purchase if it spends a total of 10,150 shirts and buys 150 short sleeve at $25 each, and long sleeve shirts are bought for $32 each? So it's going to help to highlight, as we've done before, some key info. We've got price on all shirts. How many short sleeve for $25? We don't know long sleeve. I'm thinking that's our variable for $32. And it does ask how many long sleeve. So again, long sleeve is our variable. I know that the total cost is $10,150. I can set that equal to 150 short sleeves times how much they cost, because that's the rate, plus however many long sleeve, maybe I'll call that L, times 32, because that's how much they cost. So a more common way to see this, if we simplify some things down, well, 150 and 25 is 37.50, and then 32L is probably a more common way you'll see that written. So I need to subtract the 37.50 from both sides, and I'll get 6,400 equals 32L. From there, divide both sides by 32. And the number of long sleeve shirts is 200. So I'll put it back in terms of the question. You need 200 long sleeve shirts is how many that the store will purchase. And that is actually it for the first part. Make sure you got all that written down. You can use this on the exam between part 1 and part 2. These are fair game to use on the exam.